Now let's talk about binary numbers manipulation. In this sort of manipulation, in this operation with binary numbers, we use bitwise operators, which we'll dive into right now. So let's type out the print statement like we always do to display our results. Print, and now our first bitwise operator is the left shift, which is written as less than less than. So the first number on the left is our number to be shifted. And the number on the right after the operator is the amount of places to shift. So this number in binary, let's say we have 5 bits, we have 1. It's going to be shifted to the left 3 times. So 1, 2, so 1, 2, 3, which gives us 8 because this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3, which is 8. And as you'll see on the screen below, you'll get 8. Moving on to the right shift operator. It's the same thing, just it works the same way, just it shifts to the right. So let's take two numbers. Our number in question is 32. Remember, this number is converted to binary. So we have 32 in binary shifted 5 places to the right. So we have 6 bits, let's say, and this is 32 with the 6-bit 1, 2, 3, 4, 5, 6. Yep. And then we're going to shift it to the right. So what this result is going to give is 1, 2, 3, 4, 5. It's going to give 1, as you'll see in the build below. As you can see, we got 1. Moving on to our other bitwise operators, the logical ones, AND, OR, and XOR. First, let's talk about AND. AND, what it is, it takes two values, and if both are true, then the result is true. So basically, if you have only either two ones on either side, then you get 1, as you'll see here. So we have these two numbers. Oops, my bad. I changed the operand. So on both sides now, these are both two numbers in binary. So let's write them out in binary. We're not going to build this right now. We're just going to demonstrate how these numbers look like. So 1 with 9 zeros, I believe. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 1 with 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 0 with lots of 1s. The rest are 1s. 0 with 9 1s. So when we AND this, since none of these are 1 1, we're just going to get 0. So you compare each one, each bit place. So 0 1, 0 1, and so on, 1 0 all the way to the end. And you get the AND result, which will yield 0 because none of them are 1 1. So none of these are 1 1. They're all 1 0 or 0 0 or whatever. So as you'll see, the result is 0, which is just 10 zeros. Anyway, moving on. Let's talk about OR. OR is another logical operator where if one side is true, then the rest is all true. At least one side is true, that is. So let's take our number from before. We're going to take our number, but this time we're going to OR it. That's notated with this line. Is shift. On the American keyboards, is shift backslash. It's right under the backspace button usually. Now let's talk about OR operating with OR. So 1 0 is 1. We have all 1 zeros, so that means we have 1 on every time. So our result will be 511, which is 511, which is basically all these places are going to be a 1 now. So that's the result, ORed. Right? Okay, moving on. Let's talk about XOR. XOR is kind of different from AND and OR. It's notated with the caret. And let's actually change the numbers this time to demonstrate it a little better. So 60 XORed with 13. What that's going to give us, let's do that in binary first. So we have 0, 2 zeros, 4 1s, 2 zeros again. And then that's 60. This is 60. And then let's do 13, 4 zeros, 11, 2 1s, 0 1. All right. So here's our numbers in binary. So XOR, what it does, the two sides must be different in order to yield 1 or true. And if they're not, they yield false, which is 0. All right. So 0, 0, which is 0, 0, 0, which is 0, 1, 0, which is 1, 1, 0, which is 1, 1, 1. They're both the same. So it's 0, 1, 1 again, 0, 0, 0, you get 0 again, and 0, 1, you get 1. And this number should be 49. We'll test it out right now. As you can see, we built it and we got 49. So that concludes this tutorial on bitwise operators. We hope to see you next time.